Hello students, I am teacher Anuja from the WAVE Private School. Today we are going to learn about halogen alkane. This topic is for grade 11. You will find this topic on page number 267 from Cambridge International AS and A level. Let us proceed with this chapter. So, the main objectives are introduction, different kinds of halogen alkane, the reactions of halogen alkane. There are two types of reaction. The first one is nucleophilic substitution reaction and the second is elimination reaction. In nucleophilic, we are going to see hydrolysis with ammonia and with cyanide ion. And in elimination reaction, we are going to see hydrogen bromide from 2-bromopropane. Let us proceed with the introduction about halogen alkane. Students, before I proceed with halogen alkane, let me introduce two alkanes and halogen group. See, we are familiar with alkanes because we studied in last chapters what are alkanes, and we are also familiar with halogen group. So let us have a look about alkane. These are saturated hydrocarbon with single bond. For example, methane, that is CH4, ethane, that is C2H6, and propane, that is C3H8. You can see the structure of methane, that is CH4, ethane, that is C2H6, and propane, that is C3H8. And you can see what are the atoms or the elements present in halogen group. They are fluorine, chlorine, bromine, and iodine. Okay, so see, these are the halogen group and these are the structures of alkane. So let us proceed with halogen alkane. So the name itself tells us that halogen alkanes are the compounds in which one or more hydrogen atom in an alkane are replaced by halogen atom. So see student, these are the alkanes. So for halogen alkene compound, the one or more hydrogen atom, they are replaced by halogen group. And what is the halogen group atom? Those are fluorine, chlorine, bromine, or iodine. Let us see some example. Now see bromomethane. See, this structure is same like methane, but this hydrogen atom is replaced with bromine. Second one, dichloromethane. The structure is same like methane, but the two hydrogen atoms are replaced with chlorine. Okay, see, in first example, it is replaced by bromine. In second, two hydrogen atoms are replaced by chlorine. See, in this third example, 1,3-dichloropropane. See, why dichloro? Because see, two hydrogen are replaced by one halogen atom, that is chlorine. Okay, you know how this name came, 1,3-dichloropropane, because there is 3 carbon atom. So propane, di means 2, there is presence of 2 chlorine, so dichloro. Okay, so it is 1,3-dichloropropane. Let us proceed to next. Let's say different kinds of halogen alkane. So basically there are 3 types of halogen alkane, and those are primary, secondary, and tertiary, and they are attached with halogen atom, which is going to shown as X. Okay, let us see now. Primary halogen alkane. You can see the structure. Okay, now this X indicates the place of halogen atom. Okay, now see this X, it is attached to one carbon atom this carbon is bearing one C, okay, only single C. To its up and down, there are hydrogen. So there is only one C which is attached to X. So this structure is primary kind, okay. So this kind of halogen alkane is primary because X is attached to C. This C is bearing only with single C, okay. Now let us see with secondary, okay. Now see this X. This X is attached with C, and this carbon is bearing with how many carbon atoms? C. To its right there is one more carbon, and to its left there is one more carbon atom. So the X, that is halogen atom, which is attached to carbon, those are bonded with two carbon atoms, okay. They are bounded with two carbon. That's why they are called as secondary. Let us proceed to tertiary, where you can see X. See, this is X. It is bonded with this carbon atom. Now see, now this carbon is attached to how many carbon? 1, 2 and 3. Got the difference? See, this carbon is bearing with 3 carbon atoms, okay. So the halogen atom which is attached with this carbon, it is attached with 3 carbon. That's why this is called as tertiary kind of halogen alkane. So clear with different kinds of halogen alkane: primary, secondary and tertiary. Let us proceed next. Now we are going to see reactions in halogen alkane. Those are nucleophilic substitution reaction and elimination reaction. Let us proceed with nucleophilic substitution reaction. In that, the first is hydrolysis. Before I start hydrolysis, let me tell you, in every chemical reaction, there are two reactants which react with each other to give product. In nucleophilic substitution reaction, the reactant which are going to take place in reaction are nucleophile, okay. Now see, this is general form of the reaction. So that is the nucleophile, it is attached with the leaving group, and this reactant reacts with second reactant, okay. That is, second reactant is water, okay. Let us see now. The nucleophile which is attached with the leaving group, that is bromine, okay, and it is going to react with water. What is the product? The nucleophile, it attached to the reactant plus the leaving group. There is loss of leaving group. Got the point? Through the general formula, let us see the example, okay. Now see student, this is a nucleophile, okay, that is third butyl, and Br, like third butyl is attached with Br. So this is leaving group, okay, and this whole compound is going to react with the reactant. And what is this reactant? It is water molecule, that is H2O, okay. And what is the product formation? That is third butyl gets attached with water and there is loss of bromine. You can compare this whole reaction with this general formula. See, you can see the nucleophile here, the leaving group bromine, and this reacts with water. What is the product formation? You can see the nucleophile is attached with reactant. See, nucleophile attached with reactant. See, third butyl attached with water molecule. And what is the loss? The loss is the leaving group, that is bromine. See, the leaving group. Got the concept? So in hydrolysis, this is the nucleophilic substitution in which there are two steps. There is loss of bromine, that is leaving group, loss of leaving group, and then attack by water. Got it? Let us proceed to next. Now see student, we saw with hydrolysis. In that we saw the reactant used was water. In this, with bromoethane, the reactant used is ammonia. Okay, because the reaction is going to be with ammonia. So what happens when the reactant attacks the nucleophile? There is loss of the leaving group. You can see the product. The reactant gets attached to bromoethane and there is loss of bromine. Okay, then on this product, when there is again attack of amine, okay, when there is again attack of ammonia, now you can see this in this product there is again attack of ammonia. Then what happens, the lone pair of this ammonia, it removes the proton from the intermediate molecule. Okay, so see this NH3, it removes the proton from this molecule and it forms the product called amine. Got it? So when this attack this product, it is the formation of amine and ethyl amine. Got it? The substitution reaction of nucleophile with ammonia. Let us proceed with next. The third one is with cyanide ions. Okay, now see, we saw three types. One is hydrolysis, in which water was used as a reactant. The second is with ammonia, in that they use reactant as ammonia, that is NH3. Now in third, that is cyanide ion. Okay, so the reactant used with halogen alkane is CN, that is cyanide, but they are not used in its proper form. Okay, so they are first dissolved in ethanol. Okay, first they are dissolved in ethanol, then they are reacted. Okay, so see the reaction, CH3CH2, this is nucleophile, it is attached to the leaving group, and this is the reactant. And see, when the reaction take place, you can see the reactant gets attached to nucleophile and there is loss of bromine. Okay, and the product form is proponitrile. Got the point? The halogen alkane is boiled under reflux with cyanide, which is dissolved in ethanol, and the product form is proponitrile. Got this three reaction, which is hydrolysis, ammonia and cyanide. Let us see the next reaction of halogen alkane, which is elimination reaction. Okay, so now in this reaction we are going to see that hydrogen bromide from 2-bromopropane. Now see student, first have a look to this structure of propane. Okay, this is example of alkene. See student, there is double bond. You know, for alkane there is single bond. For alkene there is double bond. Okay, now see, this is the structure of propane. So when this reacts with hydrogen bromine, what happens, this two hydrogen, they are replaced by hydrogen and bromine. See the product, C, and you can see the two hydrogen are replaced by hydrogen and bromine. So we get the product 2-bromopropane. C, hydrogen and bromine atom get attached to carbon atom. These are slightly acidic, where they form 2-bromopropane. Got it? So this is the end of your chapter. Thank you.